Vaishnavi. In this video, I will walk you through my project titled Real-Time Sentiment Analysis Platform. This is this project is a fully Dockerized microservices-based system that performs sentiment analysis on text data in real time and visualizes insights through a dashboard. The focus of this project is not only sentiment analysis but also scalable backend architecture, asynchronous processing, container orchestration, and clean API designing. In real world scenarios such as social media monitoring, brand analysis, or customer feedback platform, text data arrives continuously and in large volumes. Processing the data synchronously can cause performance issues, slow response time, and system failure using you under load. Therefore, the key challenge is to design a system that can ingest data continuously, processes asynchronously, scale individual components independently, and still provide real time insights to the user. The project addresses those challenges and using a decoupled microservices architecture. At a high level, the system is composed of six main components: front end for data visualization, backend API for data access and aggregation, ingester service for ingesting incoming text, worker service for processing sentiment asynchronously, Redis used as a message queue, PostgreSQL for persistent storage. Docker Compose is used to orchestrate all services. Each service has a dedicated Docker file, environmental based configuration, health checks, and dependencies conditions. Redis and PostgreSQL use Docker volumes, ensuring data persistence across restarts. This setup closes mirrors how real world production systems are deployed. The backend is implemented using Fast API, chosen for its performance and automatic API documentation. It acts as the central access layer between the front end and the database. Key responsibilities of the backend includes serving aggregated sentiment data, exposing REST APIs, performing async database operations, providing health monitoring endpoints. All database interactions use async SQL alchemy, ensuring non-blocking executions. Fast API automatically generates interactive API documentation. The key endpoints includes API health, checks database Redis connectivity. API post fetches stores posts. API sentiment distribution returns sentiment counts. API sentiment distribution returns time-based sentiment trends. This is a health check endpoint which confirms that all critical services are connected. It reports database status, Redis status, system timestamps. Health checks are essential in production systems for monitoring and orchestrations. Now let's look at how data flows through the system. Text data is ingested by the ingester services. The data is pushed into the Redis and then the worker takes the control. The worker services consumes messages from the Redis, sentiment is analyzed, and the results are stored in the PostgreSQL. The asynchronous design prevents bottlenecks and allows system to scale horizontally. The front end is built using the React with Vue for fast developing and rendering. The dashboard displays sentiment distribution using a pie chart, 24-hour sentiment trends using the line graphs, summary metrics such as total posts and negative ratio, recently ingested posts. This visualization helps users quickly understand sentiment patterns and changes over time. The backend includes automated tests using PyTest. Core business logic and API endpoints are covered, ensuring reliability and maintainability. The project follows clean code practices with clear separation of concerns. We got a test coverage of about 96%. We can see it clearly here. To conclude, this project demonstrates scalable microservices architecture, asynchronous data processing, Dockerized deployment, real-time sentiment visualization. In the future, this system can be extended with live social media feeds, advanced NLP models, or real-time streaming platforms like Kafka. Thank you so much. Thank you.